All right, everybody. I feel like we've done what we need to do with solving systems of equations using matrices for what would be a test question using the two by twos. However, I feel like a lot of you kind of want to know, okay, where am I going to use this as I move forward with my degree? And so I want to just take a second to give you, well, longer than a second probably, but to give you an example and some ideas of where these matrices are going to come in. Because I know it's a little unusual when we suddenly go to this very I would say abstract idea of using matrices rather than systems of equations or that kind of thing. So let me give you an example. And I would say this is like a college of business application type problem. Okay. And this is going to be something you could probably do this on your own, just doing substitution or elimination or something like that with the system of equations. But I wanted to show you how the matrix part comes in. Okay. So here's a word problem. Okay, which is where most of our applications are going to be, is in word problems. And it says there's a manufacturing plant that creates lawnmowers, makes riding lawnmowers. Okay. Um, and we know that the fixed costs for this plant are $2,400. Um, and this is per day. And $1,500 per unit. Okay, so what does that mean? Okay, the fixed costs $2,400. Remember, that's going to be things that don't change. So maybe that's my rent. Maybe that's I don't know, the cost of whatever, electricity, utilities. Probably those are pretty standard. They're not very as variable as you might think, but the variable costs is 1,500 per unit. That's the variable cost. So what's that? That's going to be your materials. It's going to be your labor hours. It's going to be all those kinds of things that just pop up or whatever. Okay. If we know we can charge $1,800 per mower. Okay, that's what we know. We know we can charge that $1,800 per mower. Then figure out how many lawnmowers we need to sell to break even. Okay. And so there's work that's involved with that, but like I said, we could probably do something where we set the cost function equal to the revenue function and things like that. And some of the problems I've noticed, like in your homework, they're going to ask you to create the cost function or to create the revenue function. In this particular problem, we're actually going to be given this. So we're given y equals, and the equation is 24,000 plus 1,500. Oh, was it 1,000? I'm so sorry. Give me just a second to make sure that I've got it right. It was 1,000, and I did not. Hang on. I'm sorry. I want to make sure because there's a big difference between my two numbers, between 2,400 and 24,000. Right? Yep, it's 1,000. Sorry. 24,000 right there. I had it in the equation, but not in the problem. So $24,000, and then the variable is 1,500. Okay, so here's where they have their fixed cost. Here's where they have their variable cost, and they're saying, hey, that's your cost function. Okay, cool. And then what about the revenue function? Well, that we're gonna get the amount of money here is gonna happen whenever we have the price per unit, right? We said we could do 1,800 mowers times the number of units that we're selling. So I don't know how many that is. It's variable, right? So that would be the revenue. Okay. And in this case, they're just giving that to me, price times number of sold. That's there. Okay. So like I said, for break even, we can set these equal to each other and we can solve. We've done that before when we did the algebra earlier in the semester, but I wanted to talk about this. This is a system of equations, right? These two work together. So I want to know, okay, what the heck is going on in there? In order for me to use a matrix, and I am forcing this into matrices just because I want to see it, remember that that was always my x's. I'm going to put in a thing like this. I'm going to have my x's in one column. I'm going to have my y's in one column, and then I'm going to have some number over here. Remember, we talked about that. So in order for me to have the x's and the y's here and the number over there, I kind of need to rearrange this just a tiny bit. So let me move this around. I'm going to move this x over here. So the first equation is going to become negative 1,500x, right? Because I'm subtracting it. So it's coming over here. Plus y equals 24,000. Okay, cool. And then this one, whenever I go to move this over, okay, fine. That's also a negative 1,800 in this case, negative, plus the y. But what's going to be left over here? Plus 0, right? Okay, so there's my new system of equations, and I like that a lot better because it's easier. It's set up so this can be my first column. This can be my second column, and this can be the answer part on the other side. So I can stick those right here. Negative 1,500. There's a 1 in front of that y. 24,000. Okay. And then here I've got a negative 1,800. There's a 1 in front of that y, and this guy is a 0. Okay, so the first thing would be just putting it into a matrix, getting it to where I can see the matrix. So that might or might not be, something difficult for us to deal with, right? Okay, so hang on a second. Sorry, I got distracted for just a minute. So what I need to do is I need to take this matrix and I need to work on it. We know we want the top left corner to be 1 if we possibly can. And this guy's just not really set up for that. But if only the y's were in the first column, right? Which we could have rearranged it so that it was like that, but that's not really natural for us. We like for this to be my x's and this to be my y's and this to be my answers, right? Okay, so what can I do here to make my math just a little bit easier? I think it's going to be nice for me if I actually switch these two rows. And the reason why is because I see to get a 1 here, I'm going to need to divide by negative 1,800, right? And whenever I do that here and here, I guess it doesn't matter. I'm just thinking to myself, let me check this number real fast. Yeah, whenever I do that here and here, it's going to work out nicely either way. A 0 divided by that number just kind of goes away. Same thing here. What I just checked is 1,500 actually does go into 24,000 pretty nicely. So it doesn't matter. Let me just divide by or multiply by a negative 1 over 1,500 or divide by that guy. Okay. So here I've got, this is going to be a 1. This is going to be 1 over negative 1,500. And then when I just did 24,000 divided by 1,500, I got a negative 16. So it at least went pretty decent. That's good to know. All right. This guy, I've got negative 1,800. It's going to be a little bit ugly, but we can deal with it. I was thinking which one's the worser of the ugliness here. Okay. Whenever I go to add this guy down, remember what we did. We did this, made this a 1 first, and then we made this a 0 next. So I need to figure out what can I multiply by here and add it to there. Well, this is negative 1800. So in my head, I hear you saying, oh, multiply it by a positive 1800. And that would indeed make that into a 0. I'm not going to mess with the first column. I'm sorry. I'm not going to mess with the first row, because I think it looks great the way it is. So I just want to multiply off of this guy and add down. Okay. So we're going to multiply and add down. 1800 times 1 is a negative, or is an 1800 plus a negative 1800. That gives me the 0. That's what I was after. Okay. 1800 divided by 1500. It's not as bad as I think it's going to be. I did this math right here. Because it's going to be multiply 1800 through, that's 1800 over negative 1500. And what I'm getting there whenever I multiply that through is a negative 1.2. I hate to go into decimals instead of fractions. Oops, sorry. But it's okay. The negative 1.2, I'm going to add that to the 1. That gives me a negative 0.2. That's not bad. We can deal with that. And then the last one here, I've got to do 1800 times negative 16, which is going to give me a negative, when I distribute here, negative 28,800. But then I'm going to add that down to the 0, and that's just going to become a negative 28,800. And don't stress out that we're getting negatives here. Notice that everything just went negative on me. So that's actually going to be kind of a nice thing for us. If you wanted to right now, you could multiply both of these by negative. Well, we can't do it yet because we would mess up our 1. But we could certainly multiply this by a negative 1 and get rid of that. In fact, I think I'm going to do that. This is really 2 over 10, right? So remember, whenever I want to make this into a 1, it's like, what can I multiply this guy to make it into a 1? Well, it's going to be the negative, because a negative times a negative is going to make this guy a positive. But then think what would happen. What I need to happen is I need this to be a 1.0, right? Okay, what can I multiply a decimal by? And that's why I was like, maybe we don't love that, but we can deal with it. I think that if I multiplied 2 times 5, I would get a 10, and then I'd put my decimal place in there, I'd get a 1.0. If you don't trust me, check it on your calculator. I think I need to multiply by negative 5 here. That's my plan. Okay. Coming over, this is a 1. This is negative 1 over 1500. This is still negative 16. We're good. And whenever I do that, negative times a negative, negative 5 times 0 is 0. I just leave that alone. Negative times a negative becomes a positive, and sure enough, 5 times 1 is a 1. So that gets me the 1 right there that I'm after, right? And then I just need to deal with this. 28,800 times 5. It's a negative and a negative. It's going to be a positive. And I think this is 144,000. So it's kind of a big number. But remember, we started with 24,000. So that was a big number also. So no big deal. All right. I'm doing pretty well here. My last thing, so I want that position to be a 0. So if we remember, we're going to multiply here by something and add it up, right? Okay, so what can I multiply by here and add up to there that'll make it go away? In my head, I hear you saying, well, negative 1 over 1500 plus positive 1 over 1500 would indeed make that go away. So I'm not changing the bottom row. Going to leave him alone. 0, 1, 144,000. Okay. Whenever I multiply this number times the 0, that's still a 0. So my 1 stays in place, which is good. That's what I wanted. This times the 1 is 1 over 1,500 plus that guy. That's the 0. That is what I wanted. Okay, that's good. And then 1 over 1,500 times 144. So I don't know. I've got it right here. I'm going to divide by 1,500. I'm getting 96. Okay, it's a positive number, and that's really good for me because whenever I get a 96 here and I add it up to the negative 16, you can do that on your calculator, but that looks like an 80 to me, right? 96 minus 16. Yep, it's an 80. Okay, so we actually have our answer here, which is nice. We do have our reduced row echelon form here. That's what that's called whenever we get it into that pretty diagonal that we like, 1 and a 1 with zeros on the others. Okay, reduced row echelon form. That's what it's called. Trying to make sure I get you some verbiage, some vocabulary here. Remember, these are my columns. These are my rows. That's going to become important in this section that we're about to do in the next section. So columns and rows. Okay, so let's read it. X equals 80. Does everybody see that? 1x plus 0 y's, so x equals 80. And then I have y equals, so 0 plus y, 1y, so that's just y equals 144,000. Okay, so remember that these were supposed to be linear equations. They're meeting at a point. It looks something like this, right? And we have our solution as 80, comma 80. That's a 0. 144,000. Okay, so that's what's going on, but I'd like to interpret it for just a minute. So let's go back to here. And remember that my variable here was the X for 1,500 and for the price here. And what did that X stand for? Remember, it was the number of mowers, right? So here we have the number of lawnmowers that we have to produce and sell in order to break even. Okay, number of lawnmowers. And what is this? Okay, that was my cost and my revenue, right? That was, so what is that? That's money, right? Okay, so that's the money that I'm going to get. I'm just going to put a big dollar sign right there. Okay, whenever it's going to cost me $144,000, and I'm going to, whenever I sell them, I'm going to make $144,000. And remember, this works in both because it's the break even point. Okay. So that's kind of a look at. Now, this one, I probably just solve this one using systems of equation, do some substitution, and be done. But that is a little look at, okay, why are we bothering with this matrix theory? And what happens is, as you go along, you would see these matrices and these word problems get a lot more complicated. So again, sometimes it's a little bit easier to deal with the matrix so that I don't have to deal with X's and Y's. I'm just working with numbers. And as long as you're using those row operations we talked about and you're making what I call legal moves, you're going to be okay. All right. So that's what I think about that. Um, that's just one example. Told you it was going to take more than just a minute or a second. But that's one example of what you would see for College of Business applications here. All right. I also want to talk about 3x3 matrices. Okay. I will tell you right now, I do not intend to put a 3x3 matrix on your exam. However, I might make it a bonus question. Okay, so I can see this being a bonus question for sure. So what the heck are we talking about whenever we say 3x3 matrices? Well, I'm going to give you an example and then we're going to come back and talk about what we would do with this. So a 3x3 matrix would look something like this. 3 rows and 3 columns, and we're not talking about the augmented part. We're just talking about what happens on the left-hand side, right? This one right here, we call it a 2 by 2 because here I had 2 rows and 2 columns, and we ignored the answer part basically, right? So he's not part of what we're dealing with whenever we're talking about solving, okay? So solve 3 by 3 matrices, and here's my example. And we'll come back to him. We'll actually do him in a little bit, but first I want to talk about what we're after here. 3x plus 9y minus 24z equals 0. Okay, what the heck's going on there? I've got my x and my y like we're used to, but hey, look, we threw in a third variable, right? This is where it's going to be help out for me. So what we mean by a 3 by 3 matrix is that we're working with 3 equations with 3 variables, or you'll hear it said 3 unknowns. Okay, it might say that in your homework. Okay, 3 equations with 3 variables. Okay, we're not talking about what this is going to look like whenever I get it into a matrix, because when I actually get into a matrix, it's going to be actually technically a 3 by 4 because we're going to augment it and put that solution column in there, right? Okay, so I've got this guy. I've got 4x plus 26y minus 68z equals 34. Okay. And then I've got x plus 5y minus 13z equals 5. And we are going to do what we can in a little bit to solve that. But first, before we get to that, I'd like to talk a tiny bit about what I might do with this. Okay. So, um, first off, to set it up into a matrix to begin with, and hopefully everybody sees, hey, this one's a lot more complicated than what I want to deal with just for like elimination or something like that. But we've got all of our x's in one column, we've got all of our y's in one column, and we've got all of our z's in one column. And then over here on the right-hand side, we've got the solution part, right? The number part that's off on the other side of the equals. And whenever we put it into our matrix, we're going to put that dashed line in the middle. So you can see how the matrix is going to develop, right? Okay, so put a pin in that. We'll come back to him in a minute, well, a few minutes, because first I want to talk to you about what we're going to do. There's this thing, it's called Gauss-Jordan elimination. Okay. And basically it's named after the two people that created this piece of the matrix theory that we're looking at. Okay. So we can blame Gauss and we can blame Jordan. It's two different people that kind of develop stuff independently, but they develop basically the same thing. They're very famous mathematicians from about the 1700s-ish, leading into the 1800s. So we can blame them for this, or you can thank them for this because basically you want to make solving this system of equations a lot nicer, right? Okay, so let's talk first about what we're going to do. There's two different formats, so I want to show you both of them. The one we've been dealing with is called reduced row echelon form. Okay, reduced row echelon form. And that is exactly the matrix that I told you we wanted to get to. 1, 0 with a number on the first row, and then 0, 1 with a number on the second row. Okay, so that's what we want to do. It's reduced row echelon because we have this diagonal is ones, and then the other numbers, anything else other than the solution row or column here, anything else is a 0. Okay, that's reduced row echelon form. And I actually really like that one because we can do exactly what I just did, okay, which is read it straight off the thing. X equals this number, y equals that number, right? Because this is my X column, this is my Y. Okay, so I'll say number 1 and number 2 so that we can keep those straight. Okay, so that's why I like reduced row echelon form when we're dealing with two equations with two variables, okay? Or this guy that we just talked about, two equations and two variables, okay? I will say, I'll show you what it looks like first, and then I'll say dealing with reduced row echelon form for three equations and three variables is a lot more complicated. Okay, so what would that look like? So let's look at it. We're going to have three rows and three variables. So my first column is going to be my x, and we know the first one we want it to be a 1. And then the y in the next column, we want it to be a 0. But what about the next column? We want that to represent my z's, right? Here we just have x's and y's, but here we're going to have x, y, and z. And then we're going to have a number or a dotted line, and then we're going to have numbers over there, right? That's what we're talking about. So we'll think about it for just a second. If this is 1x and 0 y's, for this first row, I probably want this to be a 0, right? And then I'll just have like number 1, right? And then I can read it. Oh, 1x, no y's, no z's gives me some number. Oops, I left off my equal sign. Okay. So it's going to be easy to read it whenever I finish, okay? But notice I've got an extra variable here that I need to make into a 0. So it adds steps, okay? What about this second row? Well, I already got my 1 for the x, so I want a 0 here. I want this row, if I can, to be my y. Okay, so I want to read off my y. So y equals some number 2. Okay, so what do you think about the z? Make it a 0. That's what I hear. Okay, so yes, if I want to read this second row off as nice and easily as we did it with a two equations and two variables, then I want it to be a 0, 1, 0. I still don't want to deal with that z yet, right? 1y equals whatever the number 2 guy is. Okay, and then third row, still don't want the x's. I've already got my y, so I can get a 0 there. And now finally I can deal with the z, right? Z, 1z. We're going to have a third number, but I can read this straight off. Z equals whatever number 3 that is. Okay, that's really nice, and it's beautiful for reading one, and we'll do one real quickly. But like I said, it's a lot more work because I have to find this 0, this 1, and this 0 and this 0. Okay, so it actually makes it a ton more work than just when we found the one with two variables, right? That was 4 numbers I had to find. If I'd go all the way to here, I've now got to find 5, 6, 7, 8, 9 numbers, okay, between the ones and the zeros. Okay, before I move on to an example of this, notice that, oh, I'm sorry, notice that diagonal of ones and everything else is zeros. So again, that's reduced row echelon form. And a lot of times, and if you're using a calculator, that kind of thing, RREF is the way we talk about that. And, it's the prettiest for pulling numbers off, but it is more work. Okay, so let's show one. Here's an example. If I told you, let me give you 1, 0, 0, 5, 0, 1, 0, negative 2, and 0, 0, 0, 0, 1, and 12. Okay. Can you read the solution off of that? And hopefully you're like, yep, I can do that. No problem. X is what? 5. Y is what? Negative 2. And Z is 12. There you go. You got your solution, and that's super easy, right? You can also deal with other situations like those special cases we talked about. So let me give you one of those. This is going to be 103. I put the 3 in the wrong spot. 0, 1, 5, and then 0, 0, 7. Okay, so first of all, I hope you notice that it changed in dimensions, right? Okay, so let's talk about dimensions. I haven't really talked about them. Whenever we want to talk about dimensions, we say row times columns. Okay. So up there, this one had how many rows? One, rows are side by side. Two, three. So it had, this guy was a 3 by how many columns? 1, 2, 3, 4. A 3 by 4. And we write it like that, like we were going to do a 2 by 4 at the lumber yard or something. 3 by 4. Okay. So rows times column is the way we write that. Okay. And what's different about this one that I just did is it's a what? 1, 2, 3 rows, but it's 1, 2, 3 columns. What happened? I lost a column, right? I basically lost my Z column. Okay. But sometimes those things happen. Sometimes things just fall out or whatever. Okay. So when I go to read this guy, okay, I've got what? Here, this top row is X equals 3, right? And the second row is Y equals 5. And those are fine. That's not a problem. But what's this bottom row telling me? 0 equals 7, right? Well, what do we think about 0 equals 7? Is that a true statement? No, Dr. Webster, 0 doesn't equal 7, right? Okay, so we know how to deal with that. That's one of those special cases. And when I get at the end of whatever I've done, I've got this matrix and I end up with 0 equals 7. You're going to tell me what? That's not true. So this is no solution, right? Okay. So we'll still get stuff like that. What if the bottom row had said 0 equals 0? Well, that would be infinite solutions, right? That would be always true. This is a false statement, right? That's how I knew it was no solution. 0 does not equal 7. But if you had 0 equals 0, oh, now we're talking about these are two things that are on top of each other. Basically, the Z could be any number, right? Because that's a true statement, always true. Okay, so it works for all real numbers for that Z value is what's going to happen there. Okay, so that's the kind of thing that you're going to see. Okay. Let's talk real quickly though. There's also something that's called reduced form. And let me show it to you as with two variables, two equations and two variables. Okay. This is reduced form. Okay. So what this means is to get to the reduced form, you still want the diagonal of ones. Okay. And you've got to have a 0 underneath that diagonal. And depending on how you read your book and stuff like that, it'll say stuff like the leftmost element that's not a 0, non-zero, has to be a 1. Okay. So I prefer to say, okay, I got the 1 and I got the 0, and then I got this 1, but what I don't have is the 0 up here, right? If I was doing reduced row echelon, I'd have a 0 up there, and then I'd just read it straight off. But I don't have that, okay? It's not in the reduced row echelon form. It's just in reduced form, okay? These are also still useful. I don't ever normally do it whenever I'm dealing with the two variables and two equations because it's not that much to find that extra 0. But I do it whenever I get to the 3 by 3 matrices, okay? Because like I said, here I'm finding with a 2, I'm finding two variables, I'm finding 4 numbers. But if I go to 3, I'm finding 3 by 3 is 9 numbers here. That's a lot more work, right? Okay. Whereas instead of finding all of those numbers, I could find this one and these two zeros and I would be fine. Okay. So I wouldn't have to find these extra zeros up here. That's the idea. Okay. Now, it's not as pretty, but it's still very useful to me. Okay. This format that we've got here, because if I look at I can't do much with the top row right now, right? But if I look at this bottom row, it helps me. What does it tell me? Y equals what? 1y equals 5. So it tells me that. And now, so it doesn't tell me the x values, but it does tell me the y values. Now I can work my way back up and I can look at this top row, and that top row tells me, what is it? X plus, what's this? 4y, okay, equals, we know that line is an equals, -1, right? Okay. But what do we know from the second row? Y equals 5, right? Oh, I can substitute that in, right? Absolutely, I can substitute that in. X plus 4 times, it's a 5, equals -1. Okay. Well, 4 times 5 is 20. X plus 20 equals -1. And then if I want to solve that for x, I know I just ran out of space. Sorry. Subtract 20 from both sides, right? Okay. X equals what? -1 minus 20, -21, right? X equals -21. Okay, so I have an answer. Okay, it's -21 and the y value is 5. Okay, I've got an answer, and it wasn't too much work for me to substitute that 5 back in and figure out the x value, right? So that's all right. And I put it in this order, remember, because it's always x first and then y. We do it alphabetically whenever we're getting coordinate pairs, right? Okay, so -21 for the x value and 5 for the y value. Okay, well, that's cool, right? It's a little bit of algebra there toward the end where I had to substitute back in, but that's not bad. So what happens is when I had something in this format where it's reduced but not reduced row echelon, but it's reduced, I'm going to have to work my way back, okay? The kind of cool thing about that is, well, when I get to a 3 by 3, that kind of makes life a little bit easier for me. So let's look at the 3 by 3. Okay, 3 equations with 3 unknowns, 3 variables. Okay, if I did that and I was not worried about going all the way down to reduced row echelon form, what I'd really worry about is these zeros underneath the first one. And on the second column, I need a 1 there, and then a 0 underneath that. And on the third column, I need a 1 down here. Okay. I don't care what this number is, and I don't care what these two numbers are, because by using that substitution process, I can work my way back up. So let's see what this would look like. Let's think about it. Let me say number 1, number 2, number 3. Okay, this bottom row gives me what? Y equals number 3, right? Whatever that number 3 guy is. Excuse me. And then from that, I can take that back up there and I can substitute in. Okay, whatever that number is. Let me go ahead and put some down here, 4, 5, and 6. I'm sorry. So this tells me, the second row tells me 0 x's, 1 y. So it's y plus, I don't know how many number 4 z's, whatever that is, equals number 2. We don't care about that. I'm not going to mess with that. But the nice thing is, hey, now I know what that y value is. So I have numbers, right? So I can end up getting this z guy by himself. So yes, I can back substitute and I can solve. I'll do one in a second where it's not so abstract. I just wanted you to see kind of the thought there. Okay. So what's important for getting these into reduced form is the diagonal of ones. Okay. And then underneath those, I have, it's kind of like a triangle here, these 3 zeros. Okay. That's what's going to be important for me. All right. So let's see one, and let's see if we can interpret it. That'll be nice. Da, da, da. Yes. Okay, so here's an example. I'm like, do I have an example? I do. Okay, so I thought I did 1, 0, -6, and 1 is my top row. My second row is 0, 1, 7, and 0. My third row, be careful here, it's 0, 0, 8, -40. Okay, and I look at this and I say, hey, is that in reduced form? And in fact, I think on your homework in this section, it does some stuff where it says, "Is that reduced form?" And it like you actually have to um, just say what's wrong with it, or do in this case it would be one step that's a problem because I need ones on this diagonal, right? And I need zeros down here. I've got everything I need except for this 8 should be a 1, right? Okay. So all I care about right now is making that third row so that this guy is a 1. What can I do? Divide by 8. That's what I'm hearing. Okay. Just the third row. The first 2 rows are just fine. So I'm going to copy them over. I don't want any copy mistakes. So I'm going to copy them before I do what I'm going to do on this third row. So I've got 0, 1, -6, 1. I've got 0, 1, 7, and a 0. And now these two zeros divided by 8 are still zeros. 8 divided by 8 is a 1. That's what I wanted. And this is very nice for me because -40 divided by 8 is a -5. And look, I've got that diagonal the way I want it, and all of these are zeros underneath, okay? We don't care what's going on above the diagonal there, okay? There happens to be a 0, but there's also 2 numbers that are not 0. If we were doing reduced row echelon form, we'd have to keep going and make these guys into zeros, okay? But we're not, so we don't care about that, okay? So now what? Can we read this? What is this last row telling me? Remember, this is my X, this is my Y, this is my Z. Okay. I know it's a little unusual to have 3 variables now all of a sudden, but we can do it. Okay. Z equals -5, right? Okay. Now go to this row. Don't go all the way to the top. Just go 1 row up. Okay. That row tells me what? No X's, but I know that Y plus what? 7z. Don't forget your z there. The 7 is just the coefficient, right? This is the 1y. This is the 7z. So don't forget he's there. Equals what? 0, right? Okay. But the cool thing is, again, hey, wait a minute. I know z equals -5. So I can substitute that in, right? Where I see the z right there. So I'm going to make it y plus z times -5 equals 0. And hey, I can solve that. Okay, so that's cool. Y minus 35 equals 0. I want the y by itself. I'm going to add the 35. Y equals 35. That's not bad at all. Okay, am I finished? No, I'm not, because I've only worked with the second row, right? I also want the third row because I want to know what is going on with my X value here, right? So let's read, first of all, before I go anywhere else, I'm going to section this off. Let's read this top row. What's it telling me? X plus, I'm going to write it down, 0y minus what? 6z equals a 1, right? I'm just rewriting row 1, but I'm putting in the variables so that we can do our back substitution basically. Okay? Now let's come up. Okay? I know that y equals 35, but does it matter 0 times 35? No, that's going to be a 0, right? So that's still going away. We don't care about it. Okay, but I'm writing it in there just so we can see it. -6 times what was my z? -5, right? I hear you saying it in my head. Okay, so the z was a -5. I stick it right there. It's okay. This is going to be a 0. It goes away. So what do I have? X minus 6 times -5 is a plus 30 equals a 1. And then again, I want to solve for the x, so I'm going to subtract the 30 from both sides. Those will go away. X equals what's this? Negative 29. Absolutely, it's negative 29. Okay, and now I do have a solution. And just so you know, you can leave it just like this. Here's my x, here's my y, here's my z. But there is something called an ordered triple. Negative 29, 35. This is my x, this is my y. We're used to seeing that for a coordinated pair, right? But now we've got a triple. We've got this third value. The z is a negative 5. Okay, so you can write it like that if you want to. I am fine if you leave it. Here's my z, here's my y, here's my x. Those are the same thing. Okay, now let's interpret it real quickly. Hold on. Come back up here. What is this telling me? This is a solution for my entire system, right? So when I come back up here to the original, okay, I don't have the actual equations because we started it from a matrix. But when I come back here to the original and I say 1x, I should be able to put in negative 29, 0 y's, we don't care. And then I should be able to put in negative 6z, negative 6 times negative 50. So what I've got is negative 29 plus 30, that's a 1. And it better check, right? It better check there, it better check there, and it better check there. So for instance, 8 times negative 5, sure enough, that's a negative 40. It better work in all three equations because that's what having a solution to my system means. Solution for the system of equations. It works in all of them. Okay, that's what it means. Okay, so sure enough, we've got a solution. That's cool. It maybe looks a little bit weird with the ordered triple, but this is a lot more complicated because it's got 3 equations and 3 variables, right? Okay. So hopefully you see that. If you had wanted to, I didn't want to because I didn't want to do the extra work. But if you had wanted to, you could go ahead and get the zeros up here on this top triangle, right? And get it into completely into reduced row echelon form. We could totally do that. I'm not going to take the time right now to do it, but if you want to keep on the steps, I'll show you how to do it. What you'll end up with is something that looks like this. 1, 0, 0. That first top, my x value is going to be a 29, negative 29, right? That's the number, the constant that goes with it. 0, 1, 0. What's the constant that goes with the y? 35, right? And 0, 0, 1, that was a negative 5. I actually did get that bottom row, right? When you look here, 0, 0, 1, negative 5. I did get that, okay? Because I have to get one of them in order for me to be able to manipulate it and say, hey, the z equals this, now back substitute, okay? But if I had gone all the way through, gotten this guy completely into the reduced row echelon, zeros down here, zeros up there, okay, with the ones on the diagonal, then I could just read it straight off, right? Like we did earlier. X is negative 29, Y is 35, Z is negative 5. And then I wouldn't have to do the back substitution kind of stuff. Personally, when I'm dealing with the 3 variables, 3 unknowns, and the 3 equations, I kind of get tired of trying to find all these zeros and stuff like that, but you can do it. Okay. So people ask me, what order should I do these in? Okay. There was an order for when we had the 2 by 2, right? I said 1, 2, 3, 4. So what order should I do these in? Okay. And in general, I would say you still do this one first and you still do this one second. okay? Because you want to eliminate whatever there is there, so it's not going to mess with my 1 whenever I multiply and add later, okay? But because we added the third variable, I now want to go do this 1/3. So I think about it like go ahead and get all of your columns completed as you can, okay? The weird thing is I need to do this 1/4, okay? Because I need the diagonals before I do any of the other stuff, okay? And then I'll work off of this row to get this 0, the 5th, and this 0, 6th. Actually, these two, you can interchange those if you wanted to. It's fine. Nobody cares as far as that one goes. And then I would do this column last. So 7th, 8th, and 9th. Okay. That's what I said by it's a little bit more in depth. It's a little more work. It's a little more confusing. So sometimes people don't want to do that, and that's fine. But just realize like to get my zeros in general, like this middle column's the weirdo, right? I need the 1 first so I can work off of it to make this guy into a 0, right? We would multiply it by whatever and add it down to make this a 0. So we normally do it that way, okay? Work off of this guy to make this a 0, work off of the first line to make this a 0. Once I have the 1, making these zeros becomes easier, right? Okay. Done with that column. Come over here. Make this a 1. Then make these 2 zeros. It doesn't really matter which way. Okay. Because I've got my 0. I've got my 1. I'm good. Okay. Make those zeros. And then I need this to be a 1 so that I can work off of this column or, sorry, this row to make these be zeros as well. Okay. So that's what I meant by it's a little bit more in depth. It's a little bit more tricky, so to speak. You just got to know, hey, that's a little bit more work, right? So all of that leads me to the example I gave you when I first mentioned 3x3s. Okay, this guy right here. So you can rewrite him right now if you would like to. 3x plus 9y minus 24z equals 0. 4x plus 26y minus 68z equals 34, and x plus 5y minus 13z equals 5. Okay. I'm going to start out by making this into a matrix. Okay. And like I said before, I like to say, here's all of my x's. So I've got a 3, I've got a 4. What's the coefficient here on this x? It's a 1. Yep, it's a 1. 9, I've got a 26, I've got a 5. And then this column here for the z's, I'm just dealing with the coefficients. It's a -24, -68, -13. And then over here on the constant side, I've got 0, 34, and 5. And that is how I would come up with this augmented matrix for 3 variables in 3 equations. Okay? All right. Now that I've got my matrix made, I'm going to scoot up. And we're going to work on this guy to see if we can get the 1s and 0s in the right locations. Okay. I might not do the completely reduced row echelon. I might stop with just reduced instead of reduced row echelon. Okay. I'm looking at this guy and I'm going, hey, look at this first column here. There's a 1 right there. And the only number that I need in the first column that's not a 0 is I need this first guy, top left-hand corner, to be a 1. So I'm going to swap those. Okay. Rather than work for the 1 is just sitting there. I say, hey, look at that. I can swap these. I'm going to write a little bit smaller so that hopefully I can get at least 2 matrices on a line of my paper here. One of the complaints about working with matrices is they sure do take up a lot of space. Okay, and they do. You will find yourself running through the paper real quickly. All right, so did I do anything to the second row? Nope. leave it alone. 426, negative 68, 34. And I'm just going to rewrite this first row as my new third row. Okay. 3, 9, negative 24, 0. Again, as you're looking at the homework, what they do is they say swap row 1 and row 3. So I'm going to just switch them. That's all it is. But they use this kind of notation. R1 basically switches with R3. So they've got that. I just use the arrows. So I'm not worried about it. But and I'm not worried about it on your test. But when you go to do the homework, you kind of need to go, oh, what does that mean? Okay. So we'll do the next one so that everybody can see it. Okay. I've got the 1. I want this guy to be a 0. Now, I'm going to work from the first row to make this be a 0. And I'm also going to work from the first row to make this be a 0. I'm going to do them both at the same time, basically. So we'll see. Hopefully we can do it. Okay, so what can I multiply the 1 by that will add to the 4? Remember, I'm going to multiply by some number, and I'm going to add down. Right? Negative 4 plus 4, right? Gives me the 0. So negative 4. Okay. Am I changing the first row at all? No. I've got the 1 where I want it to be. And I'm just going to rewrite the first row because I'm not changing that one. Don't mess up your 1. Okay. I'm changing the second row. And I'm going to remember you need to kind of distribute this negative 4 all the way through. We're going to multiply it by everything on that first row. Okay. All right. Negative 4 times 1 is a negative 4. I'm going to add that to 4. I'm going to get a 0. Okay. And I'm going to move over. Negative 4 times 5 is negative 20 plus, I'm going to add it to 26, and I get negative 20 plus 26 is a 6. Please, please, please be careful with your negative signs here. And if you need to use a calculator, you can do it. I'm going to do it right now. Negative 4 times negative 13. I don't know what 4 times 13 is off the top of my head. Okay, 52. Okay, and it's a negative times a negative gives me a positive 52, right? Right there. Got a positive 52. And I'm going to add that to this negative 68. So it's a negative 68 and it's a positive 52. The difference there is 16 and the 68 is bigger. So it's negative 16. Okay. And then last, I multiply all the way through. Negative 4 times 5 is negative 20 plus 34. The 34 is positive. The 20 is negative. I subtract. And the 34 is bigger, so I give it a 14. Okay. Now, I think I can also do this next one in one step. I'm just trying to kind of save paper and not too much or not have to rewrite it too many times. The 1 to the 3, if I multiply that by negative 3 and add it down, negative 3 plus 3, is that a 0? Yeah. So I'm going to multiply negative 3 all the way through. I'm going to distribute it all the way through the top, and we'll see what we get. Okay, negative 3 plus 3 is a 0. That's what I was after. So now I've got the 1, the 0, and the 0. That's what I'm after. Negative 3 times 5 is negative 15 plus the 9. Be careful. I'm not dealing with the second row anymore. Negative 15 plus 9. I think that's a negative 6. Okay. And negative 3 times negative 39, a negative and a negative is a positive. That's a 39 minus 24. 39 minus 24. I think that's 15. Let me just double check myself real quickly. It's very easy at this point. Yeah, 15. To make little bitty sign errors and mess things up. It's also really easy. You sometimes just end up, oh man, I got a fraction. It's okay. We'll deal with fractions as we go. Okay. And the very last one, negative 3 times a positive 5 is a negative 15. Add it to the 0. That's negative 15. Okay. So negative 15 plus 0, negative 15. I'm just checking my signs as I go. All right, cool. I've got the 1, the 0, and the 0. I'm good there. What do I want next? In this second column, I want this guy to be a 1, right? Okay. So I'm going to do the work to make that be a 1. I'm not going to change either of the other rows. Okay. So I'm going to keep the first row, 1, 5, negative 13, and 5. And I'm going to keep the last row, 0, negative 6, 15, negative 15. So the work I'm going to do right now is just going to change that middle row. Okay. I want to do something, and whatever I do, I want to do it up here. Okay. Multiply by some number and add it down so that this becomes, I'm sorry, I just lied to you. I apologize. I want to do something to this second row, just to the second row, to make this be a 1. And right now it's a 6. So what can I do just to the second row to make 6 be a 1? And in my head, I'm thinking, well, I can divide by 6, right? If I divide by 6, 6 divided by 6 is a 1. That's what I want to do. But instead of saying, quote, divide by 6, I'm going to multiply by what? 1/6. Now, if it works better for you to say I'm dividing by 6, that's okay, because multiplying by 1/6, dividing by 6, those are the same basic idea, right? Okay, so I'm okay with that, but just be aware that sometimes, um, you're actually multiplying by a fraction. Okay, 1/6 times 0. This is why we made this a 0. It's a 0. Nobody cares, right? 1/6 times 6, that's a 1. That's what I wanted. Here's where the fraction part comes in. 1/6 times negative 16 is negative 16 divided by 6. It's okay. We'll deal with it. Okay. And then 1/6 times 14 is also going to be a fraction, 14 over 6. No big deal. It'll be all right. I'll handle it later. Okay. Now I want this guy to be a 0. This is where I was saying what I meant to say earlier. What can I multiply row 2 by in order to add down? Well, it's a 1. I think it's a 1 times a 6. Added down to the negative 6 will give me a 1. Okay. I'm sorry. Will give me a 0. Am I changing the first row? No. Leave it alone. Rewrite it so I don't make anything weird. Am I changing the second row? No, leave it alone. Rewrite it so it's done. Okay. Because I don't want you coming back in here and writing whatever I get as times 6 or whatever like that. I don't want that. This is going to stay the same. I'm only changing this bottom row. Okay. 6, and I'm going to distribute, right? This gets distributed all the way in there to the second row. Okay. This is going to be good. We're going to like it. 6 times 0 is 0. Plus 0 is 0. Hey, look, the 0 held up. That's what we want. That's why we do it in the order I told you. Okay, because we want that 0 to hang around. Okay, 6 times 1 is 6. 6 plus negative 6 is a 0. Hey, look, that's what I wanted. Awesome. Okay, so I've got a 0 there. That's what I'm after. But look at what's going to happen here. It doesn't always happen this way, but this is really cool. 6 times negative 16 over 6. Do that off to the side if you need to. Negative 16 over 6 times a 6. I'm going to put it over 1. Aren't those 6s going to reduce out? Yeah. So what am I going to get there? Negative 16, right? So this, multiplying the 6 through, is just negative 16. Negative 16 plus 15 is negative 1. Hey, that's a lot nicer. And then here, what about this guy? When I multiply 6 times 14 over 6, what do I get? 14. Yeah, that's positive 14, right? So 14 plus negative 15 is also negative 1. So that's nice. Okay, that was just scratch work. Let me get rid of it. Okay, this is really cool too because I've almost got my diagonal of zeros. Um, this guy needs to be at positive 1, and he's negative. So what can I multiply that last row by? Negative 1. Yep, I'm just going to multiply by negative 1. Okay, so what am I getting? Don't mess with the top row. Okay, don't mess with the second row. It's still negative 16 over 6, and it's still 14 over 6. That's okay. But do mess with the bottom row, right? Negative 1 times 0, we don't care. Negative 1 times 0, we still don't care. It's still a 0. That's why we do this in this order. I don't know how often I can say that. If you don't do these in the order I said, 1, 2, 3, 4, 5, and then get this one 6. If you don't get those in those order, like say, I don't know, you make this a 1 before you've got this guy as a 0. Then when you do some of these other steps, you're going to end up like, oh man, now I don't have my 0 anymore or whatever. So just be aware. Okay. Negative 1 times negative 1 gives me a positive 1. That's what I'm after. And negative 1 times negative 1 gives me a positive 1. Okay. This makes life really cool because, hey, look, this ain't bad at all, right? Okay. If you want to keep on going and make these guys into zeros, you can. You can, to get here, this guy into a 0, I would work off the second equation, because that way I'm working with this 0 to make sure that stays a 1. But to get here, to get that guy a 0, well, I'm sorry, I would do this one next. To get this as a 0, I would work off the third equation, because I want that to stay a 0. I want that to stay a 1. I only want to change that into a 0. And then once I have this as a 0, I would work off of this equation to get my 0 up here. Okay, so we can totally do that once we have the stuff in place, the zeros, ones and zeros in place. But the cool thing, look at this diagonal. We're in reduced form. That's nice. And I can totally come over here and say, what does this bottom row tell me? I'm going to rewrite it on a different piece of paper. Z equals what? Z equals 1, right? Okay, so that's my Z value. I'm good there. Z equals 1. But then I can work my way up, right? Okay, no X's. I've got 1Y minus 16 over 6Z equals 14 over 6. But what do we know? Z equals 1, right? So where I see the Z, I'm going to plug in a 1. We know anything times 1 is just that thing. Y minus 16 over 6 equals 14 over 6. And then I can totally solve by adding. Be careful with this. We're adding fractions. You can do it. Okay. That guy's going to go away. Y equals, and then what happens here whenever I'm adding fractions? Same denominator, so I keep the denominator and I add the tops. What's 14 plus 16? 30. And look at how beautiful that is. Y equals 5, because 30 divided by 6 is 5. Cool. We had to deal with a little bit of fractions, but they work themselves out. That happens a lot. So just FYI. Okay, and I need this third, the top line. I need that because I have my Y and I have my Z, but I need my X value, right? So let's go for that one. Let's read it. This says 1X plus 5Y minus 13Z, putting the variables back in, right? These are coefficients, equals the 5. Okay, so that's the third row there, the top row, but it's the third row. And now I know these things here, right? Z equals 1, Y equals 5. So I'm out of space, but I'm going to do it here. X plus Y was 5. I'm going to substitute 5 times 5 minus 13 times Z was 1. So I'm going to plug in a 1 there. Okay. And now this becomes very nice for me because X plus 25 minus 13 equals 5 combine those like terms. I've got x plus 12 equals 5, right? And then no worries, just subtract your 12 off both sides. That goes away. X equals, I think it's a -7. Okay. And so now come back up here. X equals -7. I have a value for all three of those variables, and I say, hey, that's my solution, right? Put it in a triple if you want to, -7, 5, and 1. You don't have to put it in an ordered triple if you don't want to. I don't remember if your homework requires it or not, but you'll figure it out. It goes in alphabetical order, right? It's the X, the Y, and the Z. Okay. So there you go. That is how I would solve a 3x3. Okay. Again, I will not give you one like that as a regular test question. However, I do think it's perfectly fair for me to give you one like that as a bonus problem. So if you want to make sure you can do those and study that a little bit, be my guest because you are probably going to see one on your test. All right. Let me know if you have questions on the homework. Thanks.